All right. All right. All right. All right. Hey, here we go. My name's Eric. I'm making a game. It's called the Godkiller. I'm going to demo recent progress, but I can't demo all of my recent progress. I can only demo a small fraction of it because I'm working on the final levels of the game, and there's just secrets there. I just cannot bear spoiling them. There's a emotional impact to the last couple levels of the game. I'm not going to dismantle that for anyone who might be watching it. Boy, that's quite a statement. I really hyped it. I think it's good. I think it's good. So I'll show you what I can. Yesterday, I did some nice LOD refinements. That's level of detail for the spikes. Now, spikes have a problem in that there's often levels where I want there to be a whole friggin' load of spikes on the screen, and each one has got, I measured it, 32 triangles to it, and sometimes I'll have hundreds in a scene. One I looked at yesterday, there was 462. So 462 multiplied by 32, that's 14,000 and change polygons just from the spikes. So what you can do with level of detail in Unity is create multiple versions of the same asset or the same 3D object. And depending on how far the camera is away from it, you can put in the one with more polygons or the one with less. It takes less time to render. So if the spikes are far enough away, you don't need as many polygons to show them. You can just you can represent them a little bit more crudely, a little more cheaply in terms of rendering time, and it won't really make much of a difference if they're far enough away. So I did that with the spikes. I did a second pass of that. So originally I just had them culling out, meaning they wouldn't be rendered at all if they were a certain distance away. And that was helpful, but it didn't really cover the middle ground where spikes are. Like right now, these spikes are not very close to me. They're down there a little ways. They're kind of in the middle range. It's helpful. In fact, it halves the count of polygons or triangles to have one different version that is rendered when they're this far away. So I'll show you a little more about how that works inside of the editor. It really is important. It's the difference between running at 30 frames per second or 60 frames per second. You know, it can, depending on the situation, it can take the frame rate to twice as fast as it was before. Okay, so if I go to my prefabs, I've done this with rails, grass. Grass was the first culprit. I'll end up doing it with other things too as I see benefit. Okay, spikes, spike U. So here, let's give a little demo. I get closer though. Sometimes it puts me really far out. So, okay, there it switches to a texture. A little further, it's going to cull. There it culled. Okay, it goes between a texture where it's just a flat plane with a few dots on it to actual geometry, and here it's got 16 triangles to represent these. And then I get a little bit closer, and now it's at 32 triangles. It's pretty hard to see where it changes. Right there, right there. So you have to really be watching, but right around the base of it, it looks a little more squarish. There. Okay, so if I want to kind of get an idea of what the different versions look like without it being very far away, I can turn off LD1, LD2. Maybe a better way to do this is let's disable the LOD group. There we go. All right. So here is the farthest away version. It's actually just a flat texture, a single plane with one texture on it. So it's two triangles to it. If you have a square, which this is a square, you need two triangles to make it. So that just divides it in half. I say you need, it's really like the graphic card needs, because in the language of OpenGL and graphic cards, everything that makes up the mesh of a 3D object is a triangle. And this has two triangles, so that's really cheap. So then I go to the first 3D version, and this one, it's got 16 triangles, but it looks a little bit better than you'd expect because of this feature called smoothing. What smoothing does is, well, let me say it the stupid way, then I'll say it the smart way. Smoothing just makes it look like there's a lot more polygons than there actually are, and it kind of interpolates to give you the same feel that you'd have if you had actually a lot more polygons to go around this area. Okay, now I'll say it in a more detailed way. Okay, there are trying to demo something just doesn't make it easy. All right, so there's four sides to these things. They're like pyramids. Okay. Now each surface has something called a normal, which is like a vector that is used to express the angle that the surface is at. And a vector is just it's just a number. Well, maybe it's three numbers. Let's say, like, if you drew a line straight out from the surface here, what direction would it point? Okay. So each one of those surfaces has got this vector, this normal, that expresses how it's tilted. What smoothing does is it says, okay, if you're going to be sampling a point for the purposes of rendering a texture, we will change that normal so that it is like the difference between the normal of this surface and the normal of this surface for any point in between those two surfaces. So it kind of pretends, while it is calculating the normal, that it's continuous between these two surfaces, or any other two surfaces. Not these two in particular, but I'm just being more concrete by saying these two surfaces. Any two surfaces that have smoothing will have their normal interpolated as you move in space between the two different surfaces. Okay, so the end result of that is that, yeah, it looks all blocky down here because it's just a bit of magic on the normals. We didn't get to say that a whole geometry is implied, a whole new mesh is implied, but we did get to say, for the purposes of rendering textures and light on those that falls on those textures, that the normal will be something different depending where you're hitting that object in your rendering. Okay, So because I have smoothing, it really allows me to greatly reduce what this looks like and still get some okay. It allows me to greatly reduce the mesh or the geometry of the object, but still get the same kind of look of a smooth spike all the way around. Okay, except for at the base, and that's where you can still see it. All right, so that's the medium one, and then here is the best definition one. Now I could even go further with this, because there are times when the spikes are right next to you, just like right next to you, and it would be pretty cool if you couldn't see like this bit of straight line around here, like they would just look smooth all the way around. And this is something that I can come back to and add back in. So I could say that if the spikes are this large, let's go ahead and make this really smooth all the way around. You go a little bit further out, no, it doesn't matter anymore. Maybe even we could say even here, let's have 32 sides around this instead of 8, and it would look smooth as a circle. I may still do that with those spikes, but even more importantly, these block pads. Discard the changes. Okay. So I did already upscale the model on this once. But these guys here, when you get real close to them, if they happen to be real close to you, yeah, you see this bit of chunkiness there. So LOD is great for this. Like if you have a point of view where one object is really close to you, it probably means that a whole bunch of other objects aren't being rendered. And it's not a viewpoint that is going to suffer a lot from having one of the foreground objects that's very close to you have a lot more detail than everything behind it. So I anticipate quite a few objects will get updated with LOD. It's been the most dramatic tool for improving the frame rate that I've used, and it's quite easy to understand. Doesn't seem to have any bad trade-offs to it, and every time I've used it, everything got better. So it's one of those cases where I'm happy about something Unity is doing, and it's actually brought me value, and it's performed some work that would have been pretty hard for me to do on my own. The interface for the LOD group is excellent. It's very easy to figure out. It's not more complicated than it needs to be. It has good power. So yeah, real happy about that. Okay, so I'm going to do a bunch of work off stream today. Before I go off stream, I'm going to give a quick tour of the source code in my project. I'm not going to go deep into any particular source file. I just want to give some idea of how large this thing is and all the stuff that's in it and all the capabilities that I have. So I'm going to do a kind of a forest instead of trees view of the source code. I installed a source line count this morning. I have, and these are not third-party asset files, these are my files. I have 25,000 lines of code and 429 files. I don't think all those files that were read were source code files, but I definitely have hundreds of source code files. So then I'll go into Writer and I'll show you what some of this stuff does. Here is the data file that shows a list of all the levels I've got and does like some mapping to the name that's shown within the game versus the name in the scene. There's what we got here, like 46. I've got 2 more levels beyond that. I think it's 48. Maybe I'm up to 50 now. Okay, so that's the streaming assets has files that I've generated that are part of what the game needs at runtime. So I've got I haven't used it much recently, but I've got an ability to have animated hand gestures. They can be stored here. Level thumbnails. There's one for each level. These are taken automatically whenever the level is saved or I run pre-processing on a level. Okay, lips. This is an animation format that's used for tracking the movements of lips when audio plays. I have a tool that can be used to create them. Just a file format that I came up with for that. Metadata includes the levels JSON that I just showed. Feels like I'm missing. Oh, preprocess. Yeah. Okay. So all of these files, each one corresponds to one level, and delete a couple that I know I don't need. They contain information about the level that is generated by the pre-processing activity, and it doesn't need to be performed at runtime. There's a lot of things that you could do when the game is playing at runtime and the level's loading. They actually take a fair amount of time and can add, seconds, tens of seconds, in some cases minutes for the path mapping stuff, if they're performed when the level loads. But if you do like this sort of hard work during pre-processing, which is just in the editor, and it saves it to a file, all that I have to do at level load time, at runtime, is load in that pre-processing file and take the results of all those calculations that were performed earlier. So there's some structures that are generated, like height maps that are performed by ray casting all over the level and stuff like that, and path mapping that are in the pre-proc file. Okay, what else? So let me just sort of collapse all of this so it can be seen at the top level. Alright, so I suppose I shouldn't count any files inside of here against my source code count. So these are third-party source code. So in Unity, there's libraries that you import, and I've got some of those. They're not included inside of this file. This is whenever I find something that's not in a library or package that I want to import, but just a little bit of code that somebody else wrote, usually contained in just one file or a snippet, then I move it over here. I'm really careful. I'm really careful to look at the licensing on each one, and I'll note any licensing stuff that might be important to me. I'll note where it came from. So this has got the licensing information here. Most of these files, they just have something that was created by the author to describe the licensing, but this I added, like, here's where I got it from. Because what can happen is, it's never happened to me. It's never happened to me once. But what could happen in theory is that somebody released some source code, and either they didn't understand how they were licensing it, or they changed their mind about how they wanted to license it, or they saw my project and they didn't like my project because it's got like stuff about being in conflict with God inside of it, which could offend them, and then they want to change their licensing or say, no, you don't have my permission to use this. If they publicly license their source code at a certain point in time, that's what stands. I can go to the Wayback Machine or something and say, okay, I grabbed this source at this time. I can also go back and look at my old YouTube videos and say, look, I got this on 8/28. At that point in time, you had it licensed in the following way. So it's a record just to protect me. And I'm very careful to put any third-party source in its own directory so I can keep track of it and I have it be all interspersed in mine. I'm a great fan of open source and open source licensing. I just don't have faith that everyone that uses open source licensing actually knows what they're doing. Okay, aesthetics, it's just like a general bucket for classes that are more visual. It's also a bit of a junk bucket, if I'm honest, because I try to put everything in a bucket where it goes, and then every once in a while I don't seem to have something more specific to put one of these things in. Like, it's not about animation, so I don't put it in the animation one, but it is presentational. Okay, then I stick it in here. Okay, so there, inside of here, there's a couple of shaders, one that's actually being used, the outliner. There's some stuff about the apple of infinite travel, infinite speed. Let's see, stuff about making the lights blink, the animations around the birth egg, home egg being changed, clouds in the background, stuff about screen resizing, stuff about the maw, which I'll get into later, and a whole bunch of things under these. Like, there's these things called grid flies that are shown in the first level. I may reuse them again to kind of give hints to players about things that are interesting. In the egg had all kinds of stuff because it was a very customized level. It's the very first level of the game. Stuff about lighting, the tile shading stuff will be interesting. There's auto tiling code in here, and there's some custom code I made for making trails behind objects that are moving, which is used for the blocks. Okay, so that's all that stuff about aesthetics. Animation. Really, I could almost just rename it to character animation, except, yeah, it's for faces and body movements and stuff like that. Okay, audio, I've done a ton of stuff with audio in here. There's like a karaoke player type of a thing. All the sound effects will be played, all the melodic sound effects will be played in a certain key, which can be timed to music, and there's code there to time all the keys to music. This is pretty well normalized, so there's individual classes for notes and chords and music keys. There's code for analyzing MIDI files and generating some pre-processing data that will be loaded in, so that instead of looking at the music file at runtime, I can just have the results of it and play it. Okay, so that's audio. Boot, there's a whole bunch of things which I say I don't want them to load or unload when you go between levels. So everything that's in this object called the booter, it just stays loaded all the time. So there's this stuff for sound effects and songs. It's like I don't want a song to cut out when I go from one level to the other, because maybe it's a nice way to transition is to hear that song continue to play. So that's why I would have the song manager in the boot object, or things like that too. Just kind of essential things like loading levels, showing text on top of the screen. That's in the boot. Stuff for camera movement. Camera movement in the game is pretty sophisticated. It will move the camera automatically to where it thinks the best position is to see what you're doing. And it's something I work quite a bit on. I'm really happy with the results. Doesn't seem like I need to mess with them any further. And I'm also a little bit proud that in this game there are no controls to manually move the camera, because the camera movement algorithm is probably good enough. So I wanted to free the player from having to worry about managing the camera. That is done. Dialogue. There's a ton of stuff for character dialogue. There's the lips animation stuff I referenced before. There's some like glue code like this that says a certain game object on the screen is going to be responsible for the speech of a certain character that's scripted out. There's some dialogue generators, which are like reusable ways to put text together with a little bit of intelligence to them. So babbling is where you have a set of phrases that you say randomly. So like if I was like trying to cajole a character, or if I have one character who's cajoling another, they go, "Oh, come on. Oh, please, God, come over here. Just come over here. Yeah, just go over here. Yeah, would you follow me, please?" Something like that. Okay, so you come up with like maybe 20 phrases, have them played back randomly, and it's a little bit like a deck of cards. When you get to the end of the pile, shuffle them up again and go through them again. So you can have a character that just continues to speak, and there's some variety in what they say, but it never ends. Chant speech is just a repeating set of phrases that happens again and again. Nag speech, it's got a little more logic around escalation, where you might say one thing and then the player's not following what you're asking, so it goes up to the next level. Okay, so there's those things that help build common patterns of dialogue quickly. Persistent audio, some stuff for recording and storing audio while in dev mode as a way to kind of flesh out the dialogue more quickly. A lot of stuff about speech clips and loading in the event information that goes along with them. Spiel speech. Oh, that one's interesting. That's like somebody has a big, long thing that they want to say, but it's interruptible. So, like, if someone wants to say a lot of background story about, this building here, my father built it when he was 3, and then my brothers and sisters, they all worked on it together, and then the game refuses to have cutscenes, right? So then suppose while that person is talking about that, the main character goes over and stands next to some other interactive element, like a wishing well, and just kind of interrupts the guy and says, "Can I make a wish?" Okay, so then the logic of the spiel speech will allow that spiel to be interrupted, and there's stuff like kind of like off ramps and on ramps to go back into the spiel. So like maybe the guy who was talking about the building, he'll say like, "Yeah, make a wish if you want," and then he'll say, "And as I was saying about this building and my brothers and sisters," and there's ways to get back into what he was talking about. Okay, so that allows for some more variability in the dialogue and have it be a little bit more natural, and not hold the player hostage so that they have to always be paying attention to whatever long ass thing that the character is talking about. They can interrupt it a little bit, just like real conversations, right? Okay, so all that is there in dialogue. Discovery, these are all the objects which are used kind of like glue to take the game objects that are present in the Unity scene and to represent them inside of logical data structures. Okay. Okay, editor, this is like a lot of specific stuff. This is code that is meant only to run inside of the editor. Okay, so there's just a ton of stuff in here. So there's things with audio analysis I touched on earlier. Stuff about cables, which I haven't used in a while. I may pull them in. Cables are these hanging cables that they use a catenary curve. I tweaked that function a little bit so that it could be 2 endpoints that aren't at the same height. But anyways, like think of sloping cables with some slack to them, and there's some code here that renders out meshes to fit that pattern. Diagnostics, there's a whole bunch of stuff in here about, I just want to figure out something about the level. Like what are the bounds of all the active game objects in the level. What does my height map look like? I've been referring to this one a lot. What are the in-world coordinates as opposed to the scene coordinates? So lots of stuff like that. Level decoration. So there's procedural generation of details that I tend to add when I'm at the very end of level design. There are things like going back to here. Jeez. Try to show something quick, and Unity wants to put me like 5 miles away from all the scene stuff every time. And my fog is pretty intense here. Okay, so like if you see all the edges of these floor pieces, they've got like this sort of aluminum looking metal frame around them. You see like this pipe coming down. All these lights here, these blue lights, those are there with procedural generation by all the stuff in here. So there's a bunch of code related to that. It works really well. It saved me hours of time. Here I've got a couple utility classes for working specifically with ProBuilder meshes, ProBuilder objects. That's a third-party library. Strata, some stuff here that applies textures automatically to surfaces in game objects. Okay, so that I don't have to. I can take a cube and I can drag it around and change the size of it, and every face of it that's pointing straight up is going to get a floor texture applied to it, and all the walls will have wall textures applied. So that saves me hundreds of hours of just manually selecting the faces and setting them to what they need to be. So much stuff in here. So much. Tiling. This is the auto tiling stuff. Yeah. Okay. So there are 3 different things that use auto tiling, and there may be more, but before I'm done. So I'll show you auto tiling. Auto tiling. Alright, so here's a grass square. I'll unpack it so its prefab instancing works correctly. Okay, so you look over here, it's got individual prefabs that represent all the different things it could be. And if I just place tiles adjacent to each other, my code will select which one of the prefabs to put in. So you see, like this has a corner look to it, like it's got a corner of wood frame around there. That's one specific tile that was popped in. This one is sort of a dead end tile. It's got a frame around west, south, and east edges, and yeah. By the way, this is another one that has level of detail. So I get out a little bit further in these individual grades of glass. Grades of glass? I spoonerized. Blades of grass. They coal out, and then they cost less to render. Alright, so let's get rid of those. Grass, go away. Grass, go away. Okay, what else? Let me move through these at a faster rate. Okay, just a bunch more editor stuff. There's scene organization, which puts everything in here in kind of a certain organization so I can get to it more easily, and it also yells at me if I'm missing something. So it's a problem when you're making levels in Unity and making a whole bunch of them, that there's sort of a update to the versions of the things that you need and use in your scene as you go along. So if on the very first level you put that together, it works, it's fine, then you go to the second level. On the second level you say, okay, I want to add something here that will manage my camera movements better. And then you update everything on level 2, but level 1 doesn't have it, so you go back to level 1 and it's broken, or it doesn't have the feature that level 2 had. Okay, so the scene organization makes sure that I've got all the right game objects here, and it protects me from that. Not 100%, but pretty close. All right, some stuff for working on prefabs, some stuff for snapping objects into place. Here's the level preprocessor, the top level of it. Stuff for scanning the level. A whole bunch of stuff here. Stuff for generating thumbnails. Okay. All right. Now, I'm not going to do effects next. I'll do logic next. It's just kind of a better thing to do ahead of others. So logic, this is all the data structures and the operations on them that allow the game to be updated, except for excluding anything presentational, anything that you can see on the screen. So you could think of it kind of like if you were playing chess and you didn't have the board, or you didn't have a physical board, but you were like in like a jail cell, and you just call out, Queen's Rook to A5, whatever the stupid notation is. You know how people do that. And you don't have a physical presentation of it, but you have inside your mind a model of what that board state is, and maybe so does the person you're talking to. Or, I don't know, maybe in his cell he's got an actual chessboard. But this thing is just the pure logical representation of the game state. And it's almost entirely without anything in it that's related to the presentation. I say almost entirely because it's just convenient to hold on to one little handle to the presentational stuff inside of some of these data structures, but no operations are performed on it. It's created opaquely inside of this logic, and it's not even required. So that allows me to do some interesting things that other games may not be able to do. I've got something called prediction, where I create copies of the game state of the board. Let's start using that terminology. And I play one move in advance and see what the results are. And that allows me to do things like show on the screen a little icon that says, if you move this way, you're going to die. And it's all done because I create 5 versions of the game. One is the main one that's tied to presentation, and 4 other ones that are sort of alternative universes where the player chose one of 4 moves. So yeah, there's stuff in here for roads, which are a path mapping type of a thing. And there's a lot of AI in here. Let's say AI in like the old-fashioned way. It's not like neural nets or anything like that. Just basic AI for enemy movements. And yeah, a whole bunch of stuff in there. I think like probably half the code is in here. Okay, so now that I've covered logic, then I can go back to effects. Effects are the glue between the board and the changes that are made to the scene in response to updates to the board. So if you're familiar with model view controller, it's a pattern in computer science. This is the view part, or it's part of the view. Or you could even say it's the means by which the model and the controller update the view. So each of these structures is one change that will be performed. It could be a set of changes related to one event. So you see me back here walking around. I'll walk around a little bit more. Oh, come on. I can't do anything fast, apparently. Yeah. Okay, so if I press a key to go east, the board updates, okay, and then it returns many effects in response to the command that was issued. One of them would be piece walked effect. Okay, in here it's got all the code to play the sound effects, to update the position of the game object in the scene that corresponds to whatever piece is being moved, to move the camera in response. Okay, so all of these things are corresponding to events that happened on the board, and then they get passed back to this effects manager that will perform them all. Okay, that's that. Faces, there's some code which we haven't seen too much of that would allow us to show a face over the top of a character that's speaking. Let me see if I can turn that on real quick. Maybe it's not a big deal to turn it on while the game is still playing. So let's go player. Let's go inspector. There we go. So if that's turned on, then the face will just always be there. But it's got stuff for like the eyes to focus on whatever target you want in the scene. It's got stuff for the mouth to be animated, following kind of, well, Blair Visemes. Blair is a classic animator, Disney animator, came up with a mouth chart for animations. Okay, it's got 11 different emotions that can be displayed here, and blinking, and you know, it's a puppet ready to be animated, basically. Okay. What else? What else? Faces. Guides. Okay, so there's different things that pop up around the player that show the results of the actions. So this is the visual representation of what I was talking about before with the predictions. Is that going to annoy me to have this face up all the time? I don't know. Let's leave it. Okay, there's also flinging, and there's like a bunch of code for displaying these guides here. Okay. Hands. There is a lot of stuff for hands. Okay, so there's these two hands that are God in this game, and God doesn't have a face, he's just got hands. But I spent a lot of time working on this, defining a way to play back hand gestures while the audio is playing for God. And it works. It works fine. There's just no point in me authoring the gestures until I have the final audio, and there's no point for me getting that final audio until I've got all the dialogue written, and there's no point of me having all the dialogue written until I've got all the levels done. So trying to get to all that, it'll happen over the course of a year, and then we'll start seeing the hands come in with nice animations. I think it'll be very impressive. Some stuff abstracting over input, keyboard input. There's a whole thing that you can use to select levels. So this is my level selector. Alright. That text that appears over the top, that was added recently. That's in the booter. Okay, what else? Already did logic. Made a UI. What's this? Oh yeah, all the little menus that pop up that I just showed you, like saying you want to restore the game, you want to abandon your current progress. Okay. Custom particle explosions. So I wanted to do some things that were more specific than what the built-in Unity particle explosions would allow me to do. So I wrote my own particle explosion tool. And it basically lets me be very deterministic in calculating what the particles should do. They end up being pre-calculated, all the positions of the particles. I have noticed, never mind, no tangents. Almost done, let's keep going. Typing, there's some stuff here about synchronizing types. So there is like an interface built in, there's probably more than one in C#, but the one that comes to mind is serializable. And I looked at that for a little bit and I realized I needed some other stuff. Serialization in C# is inefficient in many ways. So the task I had was something that's different, though has similarities, which is syncing. So if you have two instances of an object and you want the second object to become like the first, one way to do that would be with serialization. You would just make a deep copy of the object. Actually, what I said there has ambiguity to it as well, because you could make a copy by serializing and deserializing, which takes all the contents of one object, puts it into a kind of a packed format, and then you unpack it into a new instance of the second object. That's one way. That way is super slow. It is the correct way to maybe save things to files or save them to disk, but it's not great if you are starting in a runtime environment where you have two instances of an object. You just want the second one to be like the first one. So I created an interface which allows you to, without performing any allocations or intermediate formats, just copy the values from one to the other. It's pretty much like an override of a equal operator, assignment operator. It's the same type of work that you would do, but I've never liked overriding operators when it wasn't really clear what the use of that operator would do. I prefer to have a method be called that's very explicit about what you're doing, instead of saying you're going to do your operator equal assignment, then somebody's got to worry about whether or not it's using the default equal assignment operator, or if it's using a custom one. So anyways, all that, almost the end. Util. Whenever I think of a set of common functionality that doesn't need any state to it, it doesn't seem to go in one of the other groups, I put them in here. So, like, for example, there's one called app util. There's it's got something called exit, which will exit the app in either the player build or the editor, stuff like that. There's stuff for coordinate system work, directions. And these are good too, because they keep me from writing redundant code. There's been many times where I got like a idea to write a function. I said, well, I should just check and see, did I already write that function? If I did, since it's related to directions, it would be in direction util. And then I go in and say, okay, well, here's something to get the opposite direction when you pass in one direction. So if you pass in north, you get south. Okay, I don't need to write that function again. I'll just reuse this one. I've done that many, many, many times. Okay, so all kinds of stuff in there for that. Anyways, that's it. That's the grand tour of all my source code. in the project, I can do another grand tour of all the game objects, I suppose, but I think that's enough, and probably nobody asked for the first thing, so why would I keep going? Level controllers. Yeah, this is the scripting that is specific to a level. So, for example, in one of the levels, I've got something that changes the musical key based on how high you are in the level. In another one, I've got dialogue and things that happen when you walk to certain areas of the level. So, anyways, that's it. Now I'm going to go off stream here and keep working on the game, but on secret stuff I don't want people to know about until they play the game. Alright. If anybody joined me, I hope you enjoyed yourself and got something out of this. I'm going to stop the stream now. Have a nice day. Bye.